You know, in this mad rush to get AI out the door, it feels like we're building on a security foundation well, it's starting to crack. The old rules just don't apply. Today, we're going to break down a new threat model, one that's been built from the ground up specifically to secure artificial intelligence.
So let's just start with a real gut check question for every security pro out there. Are your conventional vulnerability scanners actually AI ready? The uncomfortable answer is almost certainly no. And the reason why is really fundamental to this whole new threat landscape.
And here's the thing, this is the crucial point. Traditional scanners, they look for bugs in source code that you and I can read. But inside an AI model, the instructions aren't in a neat line of code. No, they're baked right into the model's DNA, into its architecture and all those mathematical weights. And that means we need a completely new way of thinking about and finding these vulnerabilities.
So here's our game plan for today. First, we're going to map out this new threatscape using the OWASP AI Threat Model. From there, we'll dive into the two main battlefronts, threats that happen at development time and threats at runtime. We'll compare two classic examples, data poisoning versus prompt injection, and then we'll wrap it all up with some actionable intelligence that your security teams can use right now.
So how do we make sense of all this chaos? Well, the framework that really brings some clarity is the OWASP AI Threat Model. If you're an AppSec, you know OWASP, and they've given us a fantastic new way to categorize all these emerging AI threats. Okay, take a look at this. What's so cool about this diagram is how it maps out the entire AI lifecycle. You can see it splits the world into two main domains: threats that happen during development time, before the model is even deployed, and threats that happen at runtime, once it's live and interacting with the world. This distinction, this is everything. It is absolutely the key to understanding AI security.
All right, so let's dive into part one, development time threats. You should think of these as inside jobs, right? They're ways to compromise an AI system before a single user ever even gets to interact with it.
So if we look back at our OWASP map, we're going to zoom in right on this top section here. The focus is squarely on the assets that exist during the development phase. You've got the training data, the model itself, and that entire data and model supply chain. So to put it a little more formally, development time threats are malicious activities that target the system while it's still being built. The most vulnerable points here are the engineering environment, where all the data scientists are working, and, this is a big one, that whole supply chain that's feeding data into the model. Now, this category covers things like leaking training data or even outright stealing the model. But the classic, and maybe the most insidious, development time threat is data poisoning. And that's the one we're really going to dig into.
And this breaks down the process perfectly. Step 1. An attacker finds a way to sneak malicious data into the training set. Could be at the source, could be in transit. Step 2. The model, which just learns from whatever data you give it, trains on this poisoned data, which fundamentally corrupts how it behaves. So what's the end goal? Well, an attacker can create a hidden backdoor, like, say, making the model classify any email from their domain as safe, or they could just degrade the model's performance to sabotage the whole thing.
Okay, so now let's flip the script and look at the other side of this map. We're talking about threats that pop up after the AI has been deployed. These are the runtime threats, or as OWASP calls them, threats through use.
All right, back to the diagram. See, now we're focused on the bottom half. You see those arrows for input and output? That's where all the action is now. The attacker isn't messing with the training data anymore. They are interacting directly with the live operational model.
And what's wild is that these attacks actually use the system the way it was meant to be used. They happen right through the normal user interface or an API, exploiting how the model interprets and processes all the data it gets from the outside world.
This category covers a whole range of attacks like evasion, where you trick a model into misclassifying something, or even denial of service. But when we're talking about large language models, the big one, the one everyone's talking about, is prompt injection.
Now, to really get this, just think about something we all know and, well, love to hate: SQL injection. With SQL injection, you trick a database by stuffing database commands into a user input field. Prompt injection is the exact same idea, but for an AI. You're injecting malicious instructions into a user prompt to trick the language model. Yeah, the source material we looked at just nails this definition. The attacker crafts a prompt that convinces the model to basically ignore its original programming and follow the new malicious instructions instead.
Okay, so now we've got our two main characters, right? Data poisoning, the development time threat, and prompt injection, the runtime threat. Let's put them head to head to really hammer home the differences.
Man, this table just lays it all out so clearly. Look at the lifecycle stage. Poisoning is in development, injection is at runtime. The target's different. Poisoning goes after the training data, injection targets the live UI. Their goal is different. Poisoning wants to corrupt the model's core, injection just wants to bypass the guardrails. And this last one, this is a game changer. The required access. A poisoning attack? That takes some serious, almost insider-level access to the data pipeline. But a prompt injection? All an attacker needs is access to the same input box any normal user has. That right there fundamentally changes the threat model.
Okay, theory is great, but what do you actually do with this information? Let's get practical and talk about what this means for the folks on the front lines, the red teams and the SOC analysts.
All right, for all you red teamers out there, listen up. The game has totally changed. Your new mission is to think like an AI adversary. This means going way beyond traditional pen testing. You've got to do dedicated adversarial testing, build out libraries of clever prompts designed to break the model's rules. And you're not starting from scratch here. Frameworks like MITRE Atlas give you a structured playbook of AI attack techniques to guide your entire campaign.
And for our SOC analysts, the blue team defenders, your world is getting bigger too. To catch data poisoning, you gotta shift left and start monitoring the integrity of the data supply chain. That means file integrity monitoring on training data, auditing access logs. To catch prompt injections at runtime, you'll be digging through API logs, looking for weird payloads, like prompts that have code snippets in them. And most importantly, you'll be working with devs to implement strong input and output validation to clean up prompts before they ever hit the model.
And that really brings us to the big, lingering question, doesn't it? We've just barely scratched the surface of a security field that is evolving at an absolutely incredible pace. As these AI systems get more and more autonomous, the old idea of a simple, defensible perimeter, it just vanishes. So the question for all of us is, how are our strategies for monitoring and response going to evolve to secure a future where the threat isn't just at the front gate, but it's baked into the very logic of the systems we're trying to protect?